do another test. So we can test all the way through, 1 microsecond, let's see. But remember, you'll have to save all of these traces. Now at the end of the day, print them out, and you've got multiple traces at different wavelengths. Now you need to try and establish what's going on here. It's complicated. There's more to it. It's not just like doing one OTDR test. It's impossible. You can't just do one acquisition. Okay. At least with this pulse, we can see there's actually another event at 3 point something kilometers, which is actually the feeder side of the network. Outside, from the pop, outside, there's a dome joint. It's got quite a high loss. This one is a 1 dB, roughly, according to the box. We'll see now.
But now we have the
We miss
Both splitters because of the pulse width.
How far are the splitters apart?
100 meters.
So it merges that 100 meters.
Yeah.
Huh?
Yeah.
The dead zone is so big. Huh?
Yeah, so a 1 microsecond pulse is equivalent to 120 meter pulse. So it's any event within that range, and it doesn't matter which OTDR, it's an OTDR phenomena. It's one of those things.
Okay.
120 meter pulse is equivalent to a 1 microsecond. 50 nanoseconds, 5 meters. 100 nanoseconds, 10 meters. 275, 27.5 meters, roughly. It's not 100% accurate, but it gives you an idea. So guys, all of a sudden now, you can see here,
Even if you
event number 1.
if you use a long coil, long launcher cable.
Yeah, still. We're using a long launch coil.
Look,
It's a kilometer.
look, the problem is the dead zones are just getting so.
Yeah.
So
Remember, when you use, what is the launch coil for?
Yeah, the launch cable serves to eliminate the zone or reduce the zone.
no, it's to see the
I
connector. I want to see the
Yeah, see the
reflectors on the panel.
So there's no way that
Yeah.
if you use a 1 microsecond pulse width, that
no way
1
to
microsecond
avoid.
is used for the entire link. Okay. The only reason why we use a launch cable is to separate the OTDR's connector from the customer's panel, so that we can certify the panel. That's the only reason why we use a launch
But you have a
cable.
dead zone in each
Still
connector
16.
that you have around.
We're going to have a dead zone.
Yeah.
You have it
Yeah.
on the.
Yeah.
But
That's correct.
according to the manual and book,
Yeah.
I don't know if I'm correct. They wrote that to eliminate
Dead
the zone, you have to use
cable.
launcher cable minimum 20 meter to 1
Kilometer.
1 kilometer.
No, the launch cable does not.
According to the books.
No, where's the book? Bring the book.
We
No, no, cable.
Even manual from Exfo, manual from
No.
Palms. I read a lot.
No, it's not dead zone. Dead zone is determined by your pulse.
Yeah.
We
Launch cable-
check in Google.
Yeah.
Launch cable
Confirm.
take your launch away from the test point,
From OTDR.
so that you can look at that reflectance there. Because if I just take a patch tail, then my launch, my OTDR and that panel is one event. I can't separate the two.
That's the only
Even
reason why
50
we use a
meters
launch
is
cable.
going to help you
Yeah.
already.
So you can see here, I want to show you something. Okay. So I've used the launch cable now, a 1 kilometer launch cable. Do you see this spike here? Can you see the distance here?
It's a lot.
It's a lot. Eh? So if you had to guess, so remember we're using a 1 microsecond pulse, okay, which is roughly anything between 100 and 120, 130 meters. So this is kilometer scale. So there's, what's it? 1, 2, 3, 4, 5. So it's 200 meters, this. Okay. So if you measure the distance in between the legs here, it's 200 meters odd. So if we look at reflective events, that spike we see, the higher the spike, the higher the reflection. But because of the pulse width, can you see it, the loop it makes? It is basically the amount of, this is basically the amount of distance it takes for the OTDR's laser to settle before it can measure the rest. This is the dead zone.
Dead zone.
That's
The
the
end
dead
dead
zone.
zone. The end of.
Yeah, that's the dead zone. If I have a connector here, I will get the same effect.
Okay.
Each connector.
Again.
Were
Each
you
connector.
asleep when we looked at Kevin Perez's
Yeah.
presentations?
That's why.
No.
He spent a lot of time on this whole topic of dead
Yeah.
zone
Yeah.
and pulse and launch cable.
I saw even this one in the beginning, in the middle, it was measured. I saw the video. I'm talking. If we now go to Google and write
Google. Yeah.
how to eliminate this on Otdr, and I did it now.
Yeah.
Lunch cable.
What
Launch
do you
cable.
get? Yeah,
Launch
launch
cable.
It tells.
This is
Yeah, it's a.
I read it.
An OTDR and test a light, a loss,
With
locate
test
brakes, splices, whatever.
Right.
To overcome a limitation of this
Oh.
OTDR dead zone.
Otdr,
Okay.
acho que ajuda.
It's a common thing we see. It's a lie.
Because I till now
Yeah.
I know that to eliminate even to
But I have the same idea.
yes yes I read
It's a
it,
wrong idea that
I like to read
sharing.
the manual of the
Yeah.
vendors.
Yeah.
Okay, like Exfo, Palms,
Yeah.
VIV.
Yeah.
All of those manual say the same thing.
Yeah.
To
I think
avoid
what
and to
they-
see events
Mm.
close to the
Yeah.
Otdr,
Yeah.
use
Yeah.
launch cable.
So
Minimal meter
Yeah.
20
Yeah.
and maximum.
So remember,
one.
When we specify, when you buy any OTDR, when you pull up the spec sheet, they will specify 2 dead zones. It's a event dead zone
Event dead zone.
Right. and attenuation dead zone.
The event dead zone normally in the middle.
Yeah.
In the middle.
So there's a reason why we say when we set up the OTDR, the reason why we want to use the shortest pulse width is for
Mhm.
sensitivity.
Okay.
So if I'm trying to, if let's say I want to jump into a hole that's here, but I use too much power, I'm going to miss the hole.
yeah.
So that's
Really?
so I need to tone the power down
Yeah.
so that I can be accurate. So what we need to remember is in each of these grids of the OTDR,
And
if
the,
I can
the-
do a drawing, but
and John, the same
Yeah.
manuals say that without the launch cable,
Yeah.
if you reduce the pulse,
yeah,
imagine you use 5 nanosecond, we will eliminate this zone too,
okay.
but we don't reach.
Mm.
We don't reach
distance.
the distance. Yeah, okay.
So one of the common questions I get asked a lot is, what length of launch cable do I need? You get
Oh.
20 meters, 100 meters, 500 meters, a kilometer. Why?
What is the difference?
It depends on the length that you're going to test.
And the pulse
If
is
you're
like-
testing, if you're doing traditional OTDR tests, okay, if you're going to be testing a 200 kilometer link, you're going to need a massive pulse to reach the distance. So for some of our customers that does long haul testing, 200 kilometers or whatever, it's at least a 2 kilometer launch cable.
Really?
Yeah.
1%.
Because they use a 20 microsecond pulse width to cover the distance. And 20 microseconds is roughly a 2 kilometer pulse. So for them to be able to certify that first connector and say from panel to the end, that is what they use. But the sampling resolution in each of these grids, what we need to remember is that this is basically, there's a bunch of data points, sampling points. With Exfo, you've got 256,000 sampling points within each of these grids. Okay? Then you get OTDRs with 128,000 sampling resolution, okay, which is less. But what it means is, if I'm sending a pulse, like at 10 nanoseconds, every 10 nanoseconds is a very short pulse width, like 2 meters or whatever. Every 2 meters, it's going to sample information and take the data points to get the average. Okay.
Yeah.
But now, if I'm using a 2 kilometer pulse, it's only going to sample information every 2 kilometers and take the average of the amount of data points and calculate that pulse width to establish the average. So, coming back to, yes, you're 100% correct. It's a thing, they call it a dead zone. But The only reason why we use a launch cable is to distinguish the loss of the first panel. We don't want to include the loss of the panel with the OTDR because of the dead zone. That's the only thing. All right. But clearly, yeah, you can see even with my 1 kilometer launch cable that I've used, there is still a massive dead zone here at 200 meters, meaning that event 4, the loss of event 4, is everything that happens at that point, including that 200 meters, whatever is in there, the loss is going to be cramped together as one event. That's why we say there's no set recipe to just using one pulse width that will go through everything. You have to use a number of different pulses.
Change
Start
setup.
short so that you can characterize the drop section.
So we IOLM.
I do.
This.
So with
I do it.
IOLM,
I
what
do it in
makes
the field.
IOLM unique? It scans the network and sees, okay, listen, I need to start with a very short pulse, like a 5 nanoseconds or 3 nanoseconds. And it does that test first and keeps it in the memory. Gets to the split and see, hang on, there's something else here. Now I need to increase the pulse. But we already certified the beginning.
A splice,
Yeah.
splitter 1, splitter
Exactly.
2. Now they don't see nothing, but they know that.
Exactly.
Yeah.
So it puts everything together in one link map view.